And thank you for joining us for this CSU Extension Gardening webinar. Today we have seed saving with Sarah Schweg. She's our Broomfield horticulture agent and director down there. I'm going to do a few housekeeping notes and then I will hand it off to Sarah. So for those of you who might not know, this webinar is one in a series of many that we've been doing. And we have a few more for the rest of the year. They wrap up in December. But next week we have basics of landscape design. We have a fun one that is a Halloween insects sort of inspired talk. Then we have a webinar highlighting Plant Select, the Plant Select program, and finally a holiday plant care webinar. So keep an eye out for those. Hope you attend all of those with us. We have your microphones muted. You can have your video on if you want, but as far as questions go, Sarah's going to stop somewhere in the middle of her presentation and we'll open up the chat box and you'll be able to put any questions you have in there and she'll be able to see those and answer those. And then there should be time toward the end to be able to do some question and answer also. And then finally, I think my last note is that we will be sending out a survey of this webinar. It's really helpful to get feedback from everyone who participates. So that will be coming out after the class. If you will all just take a few minutes and fill that out, that's really valuable information for us. And so without further ado, Sarah, I will hand it off to you.
Thank you, Darren. So yes, Sarah Schweg. Again, I am the horticulture agent here in Broomfield County. I am going to turn off my video for the presentation. We're having some kind of AV quality issues and I think it will help. And again, midway through, we will stop for questions as well as at the end. And Darren will open up the chat at both of those times. So please note any of your questions and thanks for joining us. Let's get started. All right, so we are going to cover first off, kind of why save seeds, why it's been done historically, why you might want to do it. I think we can agree seed saving is having a kind of a moment right now, hopefully more than a moment. You know, stores have been running out. Everyone's been doing more gardening and there are lots of great reasons, old and new, to save seeds. We will go over some basic terms and ideas that we're going to kind of use and reference throughout. And we'll really focus on which seeds are the easiest to save. You know, the question, what seeds can you save? You can save whatever seed you want. But we're going to operate under some assumptions that we think most beginner seed savers would have. This is largely going to look at vegetable, and some garden flowers. We'll look at the easiest kind of types of plants from each of those groups to save seeds from. And we'll look at kind of commonalities and differences. And a lot of this has to do with pollination methods, life cycle, the kind of provenance of the variety you're working with. And right after that, going through kind of what seeds you might want to save and why, that's when we'll have our first break. And so we'll do some questions at that point. And then after that, we will look at some methods and best practices. And we'll look at harvesting, processing, and storing. And we're not going to take too deep of a dive on specifics for any one plant. There are some great resources out there, many of which I will share with you that will go in more detail. But we're really going to kind of focus on giving you the background and the tools to start experimenting and have a pretty good chance of success because it's fun to play around and see what works for you. So, you know, a little bit of history here. I mean, seeds have been saved and plants selected and seeds saved and plants selected, obviously long before commercial seed companies existed. So species are improved over time. I mean, we see early on, this is domestication of wild plants to some of our known horticulture crops. Those species are improved as those species are selected for certain characteristics. They might differentiate into varieties, which is kind of the level at which we'll be thinking a lot today. And you can reap these benefits for your specific preferences when you save your own seeds. And so that's what's really great about it. It's the same concept that has been used to improve plants since always, but you get to do it for exactly what you like. So if you have, you start with a variety of tomato that you like, you choose the seeds from the earliest fruits in your garden, and you save those, plant them the next year, continue to save the seeds from the earliest fruits, you are going to improve that variety for your needs and have earlier fruit set. They're also locally adapted, and this again is like we understand that that's a big part of improving horticulture and agricultural crops, is that we want to have plants that are well adapted to the environment. But here again, when you save your own seeds, you get to have this hyper local adaptation. You're selecting the seeds that do the best in your garden, in your house, in your neighborhood, in your state. And those are the really fun things you can kind of think about going through the same process that's been employed and doing it just for you and just for what you like. So you can also keep hard to find varieties. You know, you might see something in a seed catalog and it may not be there next year. So having your own stock of varieties that you really like is definitely a benefit. You can certainly save money. I think it depends kind of where your point of comparison is, right? We all know seeds are much less expensive than purchasing transplants per se. However, there is a cost to seeds, and there's definitely a quality, a correlation between quality and cost. And you get to save money and know exactly where your seeds are coming from. Another big piece that's always been a part of the seed saving conversation is preserving genetic diversity. So if you can see this image here on the left, this is a survey done in 1903, and this was just commercial seed houses, and they had hundreds of varieties. The kind of thickness here indicates how many varieties of this type of plant were reported in the survey. And so we had hundreds of varieties of all of these types of plants. And then 80 years later, you can see how much thinner these lines are. Again, the thickness and thinness indicating how many different varieties were given in the survey. So there's a huge decline in diversity. And when you grow your own seeds and preserve interesting varieties, you're kind of doing your part to preserve that genetic diversity. And it absolutely is a way to build community. I mean, just looking at all the people who are interested in this now, and like I said, kind of having a moment before, but there are seed libraries, seed swaps. It doesn't have to be anything formal. It can be talking with your neighbor over the fence. Hey, this worked great. Oh, I love the color of that. And that kind of sharing is a big part of seed saving and a big benefit of participating in it. So thinking about just these basic terms and ideas, I want to kind of set a baseline, and we will absolutely introduce many more as we go. But so it's good to frame, to think about a seed is a living, dormant embryo. So they've got the embryo, the seed coat, we want to remember is there to maintain that dormancy until the conditions are such that the plant will have its best chances of success when it germinates. So signals like temperature, light, moisture, these are how the seed coat receives environmental signals to allow that germination and break the dormancy. So these have applications when we think especially about how we store seeds, for example, thinking about when do we want to maintain that dormancy and when do we want it to break. And then variety or cultivar, as I mentioned, that's kind of the the level at which we'll be thinking a lot today. Easy, I think, comparison is like dog breeds, right? So these are plants, or a group of plants selected for desirable characteristics and maintained by propagation. So if you have a breed of dog, you know, we all know they have stable characteristics. They've been bred for desirable traits. They can look very different from one another, and they can all breed across. They can all crossbreed. However, we know that when you crossbreed to breeds that have been bred to develop different characteristics, that the progeny of that crossbreeding is going to be totally different. So we can also think with the same point of reference about inbreeding. So a lot of very purebred dogs, if they're inbred and inbred and inbred, that can cause issues that can be passed down genetically. So we think about both these things when working at the variety level. We want to think about the ability to maintain characteristics that we want, and also the ability to maintain enough genetic diversity in the population that those seeds are going to, over time, be successful. And then pollination, we will harp on a lot. I mean, the basics are just the process by which pollen is transferred from the male to the female part of a flower, resulting in fertilization. And there are lots of modes by which that can happen. And that's going to be a big part of our conversation on figuring out which seeds are best to save seeds from, or which plants rather. And this is bolded because I want us to really keep this in mind. So the goal for beginner seed savers, which I'm assuming we are here, is to produce plants that have the same characteristics as the parent plants. And so we're not going to talk about everything one could do when saving seeds. If your goal is to create yet unknown varieties, that's totally valid. It's a little bit more advanced. So we're going to focus on kind of beginner techniques where we see a desirable characteristic in a plant, and we want to save seeds that maintain that characteristic. Okay. So keeping that goal in mind that we want to maintain characteristics. One thing we think about a lot is cross-pollination. This has advantages in nature, right? It is what helps us maintain a higher diversity in a population. So if you have a higher diversity in a population, this helps with kind of long-term adaptations to changing environments, but the characteristics of any given kind of generation or population are going to be pretty varied. So adaptations that plants use to encourage cross-pollination would be, for example, monoecious plants. Monoecious, which the Latin translation is in one house. So on monoecious plants, you have on one plant separate male and female flowers. So we're probably all familiar with squash that have this feature. So you have male flowers and female flowers. They are separate, and you can see on the right that you can see the beginning of a fruit with the female flower and not with the male flower. So by separating male and female flowers, that is a way that cross-pollination is encouraged. Even more so, but along the same lines, is dioecious plants. So this is when you have one plant that is male and a separate plant of the same species, variety even, that is female. So example of this would be asparagus. And so we are concerned, again, thinking about our goal of how do we have good fertilization without compromising the characteristics that we want. Our concern with cross-pollination is really just about different varieties of the same species. Because if they're different species, we're not too worried about them crossing. But if we have different varieties, they can easily cross and affect our desired characteristics. And this is something that I think maybe gets confused a little bit sometimes. So if you have cross-pollination the fruit that is created by that pollination and fertilization is typically, you couldn't tell one way or the other. It is actually the seeds, if you were to save them from that fruit, that's where you start seeing new characteristics or unstable characteristics. So we're particularly concerned about this in seed saving, more so than if we were not saving seeds. Because if we were just in it for the fruit, that would be fine. But we're in it for the seeds, and so therefore cross-pollination is going to be a concern. So the ways to avoid cross-pollination is various types of isolation. So we can think about variety, and so this would just be choosing to limit the number of cultivars or variety that you grow, or when we're thinking about seed saving, just limiting the number of cultivars or varieties that you let flower. So, you know, if we have any fruit-bearing vegetables or garden flowers, the whole point, we have to have flowers to get anything out of them. But if you're growing lettuce or greens, you don't have to let all of your varieties that you're growing flower. So that can be a strategy depending on the plants. And then there is spatial isolation. So let's say you do have multiple varieties of the same species that you don't want them to cross. There are, depending on the way that those plants are pollinated, there are kind of accepted distances where you can plant the different varieties far enough away from each other so that the insects or wind are unlikely, though nothing's ever certain, to carry pollen from one variety to the other. There's just simple timing, so you can grow varieties that have different bloom times, thereby keeping them from cross-pollinating. And then there is physical isolation, and there are a ton of different methods for this, depending on the plant, the mode of pollination, and kind of what's needed. But we're not going to get too deep into those because, again, we're focusing on kind of what are the easiest plants to get started with. And when you got to go into creating physical barriers, I think that is getting pretty advanced. And so all of these kind of ways of isolating and preventing cross-pollination, these are the tools that are available to you. But to know which tools you want to use and how, it's really important that you know your plant. So genus, species, variety. At the genus level, or usually even the family level, you can have a decent idea of the basics of how your plant is pollinated, and that will help you know which type of isolation you want to focus on to avoid cross-pollination. And you also really want to know the variety, not only because you don't want to cross, you know, there may be two varieties of tomatoes that the layperson eye can't tell apart. If you want to breed for certain characteristics or save seeds for certain characteristics, you still don't want those to cross. So you want to know variety. But on the flip side, so many of our domesticated vegetables that look entirely different and that we select for entirely different characteristics are actually the same species and can easily cross. So this is a great example, domesticated from wild mustard. We have cabbage, Brussels sprouts, kohlrabi, kale, and broccoli and cauliflower. So if you're just trying to get, you know, the earliest Brussels sprouts, you don't want to accidentally cross it with a broccoli, which is going to set your selection for characteristics off on a totally different path. And similarly, you know, thinking about Queen Anne's lace and domestic carrot, those can totally crossbreed. So it's important that you know that taxonomic classification and the method of pollination. And that's going to let you know how much and what type of isolation you need to maintain the desirable characteristics, which you'll do by preventing that cross-pollination. So what seeds should you save? So we want to look at that success in achieving that goal, kind of with minimal work. So we're focusing again on kind of beginner plants. And we will talk about just the items to consider as you assess whether a plant is essentially worth it for you to save seeds from or not. So one thing we want to look at is life cycle. And these are essentially in order of difficulty, annuals being the easiest, then biennials, then perennials. So annuals, completing germination to seed dissemination to death in one growing season, are pretty easy. One factor in this is that annuals rely heavily on seed production and dissemination for their reproduction. So, there will be just many seeds, and you can always get them in one growing season. Biennials have 2 growing seasons, and it's typically a vegetative, so no flowers or seeds, stage the first season, and then a reproductive stage where they would flower and then seed the second season. And at the end of that cycle, that plant would die. So saving from biennials is totally doable. You can see on the left a picture of carrot flowers and then seeds. Some issues you might run into with perennials. So for one, in most areas of Colorado, it depends kind of what protection and what site you have going in your yard. But for a carrot to stay over winter and survive, our temperatures are pretty low here in Colorado. So we treat them as an annual. We get that root. You can store them in the garden for a while, but for it to live through the winter, come back to complete that reproductive stage, the second season, probably you'd want to dig it up, save it, replant it, overwinter it somehow. So you're having 2 years rather than 1 year to even get to your seed stage. And B, you're probably going to have to put in some extra work to even get the plant to survive to that reproductive stage in the second year. And then perennials live any more than 2 years, and they will repeat that reproductive cycle annually for the most part. However, again, thinking how long is it going to take you to get to your, from seed planting to seed saving, while they'll repeat the reproductive cycle annually once they're mature, many of them will not flower set seed for a few years when they're first planted. So in your perennials, as you get kind of woodier to other issues that can come up, more of them tend to require cross-pollination. They tend to put fewer resources behind that seed production annually because it's kind of a different survival strategy, right? So that's where your annuals, that's their only mode of survival. So they're putting literally all their resources at the end into seed dispersal, whereas perennials have a different survival strategy. And, I guess another way to think about that is you will get fewer seeds from a perennial each year, but of course, over the lifetime of a perennial, one plant will produce way more seeds. So it's just things to think about, give and takes, but this is why perennials are often propagated by cuttings or divisions, is because they're definitely on the tougher side to save seeds from. So other than life cycle, you want to think about primary pollination method. And I say primary because, as we'll talk about in a bit, you can't really control these always, but there is a kind of intended primary pollination method for each plant. And these again, there's an easier to a harder. So the 3 that we're kind of concerned with is self-pollinated, wind pollinated, and insect pollinated. If I were putting those in easy to hard order, I would actually put insect second, and we'll talk about why. But so the way to frame this question is how much spatial separation do you need between different varieties of the same species to prevent that unwanted crossing? So if you don't have the variety separation, you don't have the temporal separation with different bloom times, you don't have a physical separation, you will need space between different varieties in order to achieve the isolation. And each of these pollination methods have a different amount of space required. So looking first at self-pollinated or self-fertile. So as a kind of strategy in nature, self-pollination helps maintain genetic purity. This is great for us because if we're when we save seeds, we're trying to select for desirable characteristics. Bees are the least likely to experience outcrossing. And these will be, self-pollinated plants will be often very successful short-term. Over time, they are less able to adapt to changing conditions, and that's where we get into thinking about what size population do you need to have enough genetic diversity for long-term survival. So if it's self-pollinated, we know that it's going to be a perfect flower. So that means it has both the male and the female parts. To kind of take a look and guess, you can think of many of your smaller, less showy flowers tend to be self-pollinated. This is because they're not trying to attract insects, right, to pollinate them. For your self-pollinated plants, if you have no separation between them, you may still come out okay. We'll talk about some that are kind of very reliably self-pollinating, like peas and beans, versus some that are a little less reliably self-pollinating. But really with most of these, just separating varieties by a few rows in the garden, 8 to 10 feet, should really do it. And so you're getting the genetics from the parent plant and their parent plants, and they're going to be really similarly manifested in the offspring. So peas and beans are, the reason they're pretty reliably self-pollinating is because most of the pollination typically happens actually before the flower has even opened. So they, by doing that, disable outcrossing and pollination by other varieties or species. But if you have that really reliable self-pollination, that's when we start to think about population size and how that affects our success over time. So this is just a snippet of a very extensive guide that I have included in the resources for y'all. And I want to show you, number one, we'll look at the pea, which I referenced. So we can see for any of these, the life cycle. So we have annual, primary pollination, which is self. We can see 10 to 20 feet for recommended isolation distance for seed saving. And then looking at this variety maintenance and genetic preservation. So if you're saving seeds for a season or two, you can use this variety maintenance number for population size. If you are saving seeds for many seasons and plan to continue, you want to have 20 plus plants, and that is so that you don't get this inbreeding depression. And so again, this is just one example, but all of this information, species family, life cycle, primary pollination, your isolation distance, viable seeds, variety maintenance, and genetic preservation population size is included in this. So don't feel like any of this stuff is worth memorizing, but you have great resources to reference. So in comparison to a pea that's going to be pollinated before the flower even opens, there are lots of plants that are self-fertile. They absolutely can self-pollinate, but they may be more likely to be visited by insects. And this is essentially plants that are, or flowers of plants that are just more open and more appealing to insects. So in this category, we take tomatoes, peppers, eggplant, okra, lettuce. And so the more likely they are to be visited by insects, the more likely you are to get some outcrossing. You can focus on different types of isolation to avoid this. So maybe it's that temporal isolation. Maybe you increase the distance a bit, but these are all any of the self-pollinated plants, even if they're primarily self-pollinated with some insect activity. These are all great beginner seed starting plants, or seed saving plants, excuse me. One thing I will mention is that as you get into these plants versus, let's say, a pea, they do tend to need a little help with fertilization. So if you have no insects around, for example, you're growing tomatoes inside, let's say, they will not be well fertilized, which means they won't produce, number one, nice fruits, and they also won't produce very good seeds unless you give them some kind of vibration and it's fairly intensive. If you want to do it around the same time of day, every day for like 5 days when they're flowering. So these that tend to be visited by insects more can also have issues if they don't have that assistance with proper pollination and fertilization. And then whether it is because of insects or not, even in a pea, the offspring can still be different from the mother. So just good record keeping, keep track of stuff. Nothing is perfect. It could be due to genetic mutation that's then passed down. And then we do have about 4% or so outcrossing in these kind of self/insect pollinated plants. So next we have insects pollinated, and this is the kind of most common strategy in nature. About 80% of all plants are animal pollinated, so not just insects, but so these are like your cucurbits, your brassicas, and looking at a general recommendation for that spatial separation, if you can't have the variety separation or the temporal, recommend about 1/4 mile. You certainly have no actual control over what a bee is going to do, but it's a good kind of starting point. So here we can look at some strategies, definitely not foolproof. I've seen, and I honestly I have little but anecdotal information on this, but I think it's interesting. People creating kind of pollen buffets between, maybe they have a little less room to spare and they want to grow 2 different varieties of an insect pollinated plants. So between those 2 varieties of the same species, they will just plant masses of super appealing, usually ornamentals, like totally different species. We're not worried about crossing with the 2 different varieties. So that's, I think, kind of an interesting strategy. And then again, especially when we're looking at, so cucurbits are a little tough, but looking at the options in the brassicas up there, we do not, when we grow for food harvest rather than seed harvest, we do not want these plants to flower. So that actually gives you a lot of flexibility because you can grow as many varieties as you want, as long as you're only letting 1 at a time that could cross go to seed. And if you think about kind of how many seeds you get when you save seeds from a crop each year, I mean, you can just kind of rotate through each year, growing all the varieties you want, saving seed from 1 variety at a time each year. And lastly, wind pollinated. So definitely the most challenging on balance to save seed from, because if you were only using that spatial separation, you need to separate different varieties by 1 mile, and that's kind of minimal. So, for something like corn, which I think is one that many people realize is wind pollinated, it's really just not realistic for many people, unless, if you're living in urban or suburban areas. I think maybe fewer people know that spinach, beets, and Swiss chard are also wind pollinated. And and again, this is because we don't let our spinach go to seed, right? Why would we? That's not what we want. But up in this top picture here, so this is actually a spinach plant, and that is the female filament. So spinach plants are dioecious, so they have separate male and female plants. And if you look below at the picture of the corn, where you have the male plant on the left and the female plant on the right, so those kind of filaments on the female plant is when pollen is blowing in the wind, they tend to kind of catch and trap that pollen. So we don't often see the reproductive parts of other wind pollinated plants, but I think you can totally see the similarities and kind of picture how that strategy works. So again, for your spinach, your beets, your Swiss chard, it's actually not a problem. Spinach is really easy to save seeds from because you would only need to separate the varieties by a mile if you are letting both varieties flower, which you just wouldn't. And you know, again, with spinach versus like a corn, your neighbor can be growing spinach, they can grow any variety they want. The only thing you would have to make sure of is, are my neighbors also saving seeds of spinach from a different variety than what I'm saving seeds from? So it's a little, you know, your chances are a lot better. Corn, I think, is pretty advanced, but so saving from spinach, even though it's wind pollinated, is totally doable. All right, and this is a big one and kind of similar but different, I would say. So the other thing you want to look at when you're considering, is this a good plant for me to save seed from, is hybrid versus open pollinated. So hybrid, these have been crossbred deliberately. You know, can be actually on the genus level. A lot of times we see, species, a lot of times we see variety level. And so how you can identify hybrid seeds, they may well just say hybrid right there, clear. Or if you see F1, that means first generation, that is a first generation hybrid. So that is always something to look for. And here again, you know, if you just want to experiment, have at it. But if you're following that goal of wanting to produce new plants with characteristics that you know, and that you selected for, hybrids are not something you want to save seeds from. What's interesting about this first generation, the F1, is hybrids are bred so that that very first generation, the seeds that you buy in the seed packet, have super reliable traits. And then from there, it just kind of deteriorates and you really don't know what you're going to get. So that's why F1 seeds are more expensive. Number one, they're more expensive to produce. And number two, I mean, they can have absolutely great qualities and very specific and very reliable. It's just that they are not good for seed saving because you won't have reliable characteristics after that first F1 generation. And then, you know, it's kind of interesting to think over time, as what started as a hybrid can stabilize, can produce pretty reliable offspring. And one cool example of this, I think, is Shasta daisy. So this is a quadruple hybrid. And what you'll see when you see a hybrid species that's speciated, so you'll see the genus, and then you'll see the X, that means a hybrid, and then the new species name. So we know it's a hybrid, and then, so in this case, Leucanthum and Superbum is the new species name. Leucanthum superbum is a hybrid of these four other kinds of daisies. And so, you know, it's kind of fun over time. These were selected, and then at first they were just this group of hybrids growing together. They all looked pretty different. But then by open pollinating within that group, over time it's stabilized and giving it the distinction to now be a its own species that has basically hybrid roots. So that is basically kind of demonstrating a transition from hybrid to first generation hybrid to open pollinated. So open pollinated is what we want to focus on when we save seeds. And so this is developed naturally by some type of isolation of a population, typically either variety, you know, isolating varieties or spatial isolation, all of which can happen totally naturally, right? And so open pollinated, they don't have that super duper distinct specific characteristics all the time that your first generation hybrids do, but they are very reliably true to type. And so open pollinated are what we focus on for seeds, and just to kind of draw the, or for seed saving, and just to draw the distinction between some of the other terms. So over-pollinated varieties, they can be cross-pollinated, they can be self-pollinated. This is about not how, a flower is pollinated and fertilization occurs. This is about how the variety develops over time. So open pollinated are great for saving. Heirlooms are also great for saving. You can see here again, this is a Cherokee purple picture. So it's a good example of how we recognize this in our heirlooms. The kind of characteristics of the fruits of any given plant are pretty wide ranging, but they're going to reliably come back in that same range over and over again. And so heirlooms have just been passed down, over generations. A lot of people draw the line at 50 years, but basically all heirlooms are open pollinated, but not all open pollinated varieties are heirlooms. So to kind of sum all that up, you can save whatever you want. The easiest to save are going to be seeds from annual, open pollinated, and self-pollinating plants. And remember that you want to focus on saving the seeds from the best performing plants, the best performing fruits in your garden. You don't want to save seeds from any diseased plants. That's just kind of the flip side of saving from the best. And you don't want to save from hybrids if you want to produce true to type offspring. So we will take a little break, open it up for some questions, and just keep in mind, for some questions, I may say, we'll be getting to that because we'll be kind of talking about methods and any specifics in a few. So if you guys do have any questions, throw them in the chat and that would be great. Okay. What do you mean by vibrating? Sorry, that needed more explanation. No, I'm just kidding. I've had this issue. So literally, so what you're trying to do is to get that pollen. So I believe Candace is referring, she says, what do you mean by vibrating? And she's referring to if you have self-pollinating flowers that need a little extra work, sometimes if they're not visited by insects. So you will, honestly, like an electric toothbrush will do it. You can take a, you can just shake slightly, rapidly with your hand for a little bit. But all you want to do is create that movement that can just have the pollen moving around within that flower, because it won't always happen on its own. And you know that if you're growing inside, you kind of have that as a double issue, because the other piece that can just kind of help those self-pollinating plants along is wind, and presumably you don't have that inside either. So I mean, simply just like shaking it, but vibrating is actually the most effective. Okay, and Carol said, how old can seeds be viable? So we will get into the specifics of that in a bit. Short answer is it will depend on type of seed and the method of storage for the most part. For nasturtium seeds, are there particular methods for saving or drying? So we will get into all that method stuff in the next little section. So I'm going to hang tight on that one if that's okay. How long is this presentation? Sorry if it should be obvious. So the I think the class is an hour and a half. I don't think we'll take an hour and a half, or we won't, but yeah. I hope that answers your question. Take a second, see if we have any more. All right, thanks, Joanne. All right, I am going, let's see, in the next section, will you get to things like lupine seeds and their challenges? Yeah, so we are, again, we're not gonna dig too deep into a lot of specifics, but I do happen to mention lupine seeds, and we will talk about, also talk about the types of challenges that they have, so yes. All right. I think I am going to go on, and I will be happy to answer other questions as they come. All right. So now we're looking at methods and best practices. Harvesting, processing, storing, and record keeping is just something that kind of goes with all of these. Again, we're not going to go super duper specific, but the resources I'll provide for you have all that super specific information that you can always reference. And we will talk about some common challenges, issues that people see. So when are seeds ready to harvest? This is the timing. And, really we're going to kind of stop trying to think in vegetables and flowers now, because as we'll see, their actual kind of categories will overlap and cross versus the way we use them when we talk about seed saving. So things to remember: if seeds are not mature, they will not germinate. So seed maturity is almost always pretty markedly different than market maturity. So we have a zucchini photo on the left of getting ready to be at seed maturity. That, to me, I mean, that's past zucchini bread, right? It's way past where you want to eat the zucchini any other way. But that is what we're looking for seed maturity. So something to keep in mind for your flowers and your vegetables, that you're usually going to want to take it much longer than you would before harvesting the seeds than you would to eat them or cut the flowers or what have you. Some really broad strokes. From fruit, you want to harvest after it ripened, but before it rots. And after seeds have matured on a flower, let's say, but before they're dispersed. And we will, I promise, we'll get more specific with that. Okay. So wet seeds versus dry seeds. So this is us switching modes from vegetable versus greens. We're going to talk about wet versus dry. So wet are those seeds that have to be separated from a moist, fleshy fruit. Your nightshades, that's your tomatoes, peppers, eggplants, your cucurbits, anything with a fruit. And dry seeds have to be separated from, some type of casing. It doesn't have to be necessarily a pod. But so notice we have legumes, your beans and peas. These are a dry seed when it comes to harvesting and processing. So are your root crops and most flowers and herbs. So when you're harvesting wet seeds, again, the biggest rule of thumb is just leave it on the vine as long as possible. You can also ripen after picking. If you think about how when you're trying to harvest for market maturity, let's say to eat a fruit, of course, sometimes we let it sit on the counter, we accidentally put it by a banana, and it can get overripe. This is all good for seed saving. Ripening on the vine or on the plant is best, but absolutely you can continue to ripen it after you've picked it. And again, it's just finding that balance of how ripe can you get it before you're moving into rotting. Most vining plants can stay on the vine after frost. I think we all start thinking about seed saving in like mid to late summer, but it's something that we'll be continuing to enjoy if we want for quite some time. So certainly, I mean, even your summer squashes, I mean, it's okay for them to go through a frost. Your winter squashes absolutely should. So for harvesting wet, just try to get your max maturity. So for processing wet seed, this is where it gets fun. So obviously you have to separate from the fruit and you have to clean it before drying. So we're going to talk about harvesting and processing wet seeds, harvesting and processing dry seeds, and then they all kind of merge paths again. They need to be dried. So even though peppers, are a lot less aqueous than a tomato, let's say, it falls into the wet category. But your tomatoes, as well as some others like cucumbers, will require some extra steps. And this is a very simple fermentation. So you can see up here, we all are familiar with this kind of gelatinous seeming coating around tomato seeds. So that is, among other things, designed to help that seed maintain the dormancy. So we don't want that coating on because we're going to want to break that dormancy whenever we want. We don't want it on, obviously, when we are saving the seeds, because we want them to be dry, and it would be impossible to dry them without removing that coating. And were you, to get some seeds through and then plant them, this coating can also be kind of appealing to animals and make the seeds more likely to just get dug up. And as you can imagine, storing seeds with that coating is not a super viable plan. So for fermenting, you're just going to slice open whatever it may be. We have a tomato example here. Scoop the seeds into a container. Glass is ideal. Cover with water, maybe double the volume or so, but you don't want to overfill because you're going to get some kind of enzymatic action and some bubbling. And cover the container and either shake it or stir it, what have you, but get everything kind of nice and mixed together. And then you're going to leave it be. You're going to either shake or stir that solution 1 to 2 times each day for 4 to 5 days. And so just keep in mind, depending where you're having this process take place, that the fermentation is going to happen more quickly at higher temperatures. But in my experience, after 5 days or so, that should handle it. But were you doing it in a hot, unair conditioned kitchen or something during the summer, it might be even less time. And so you're probably going to see some mold, definitely just some gross stuff. Everything up to and including mold is totally fine. That's all going to float to the top. And so you can just scoop that off. And once you see that kind of visible separation, that's when you'll know it's done. It's going to smell quite bad, so you want to think about that as far as where you place these. But you'll have your mold and that coating and all other materials up at the top. You'll also have any non-viable seeds up at the top, and your viable seeds are down at the bottom. So actually a pretty passive process. Once you've seen that separation, you can scoop out the stuff you don't want, strain, and then of course we'll commence the drying process, which is what we're going to have to do with any seeds. So looking now at when do we harvest dry seeds. This, again, there's no hard and fast rule, but it is useful to think about how are those seeds, like what happens to those seeds if you don't harvest them. That's how I think about it. And if you don't know the answers to these off the top of your heads, again, that's okay. All you have to do is just observe. Let a flower go to seed and see what it does. So one kind of category is the seeds that are in pods that are going to burst open. So when the pods have fully dried, they'll explode and they throw out the seed, milkweed. For example, I think we can all relate with. And for these, you want to harvest when the pods are dry, but you obviously don't want them to open because they open sometimes pretty fully very quickly. So this is something that once you think you're getting close, you want to check on them daily. And even if you're checking on them daily, collect in the morning. You're going to collect the pods in the morning because a lot of times it's that little bit of heat and desiccation in the day that'll cause them to just pop and go. So this is like your milkweeds, your sweet pea, lupine, California poppy, anemone. And these are called dehiscent, but so you want to get them before those seeds have gone everywhere but where you want them. And then there are pods that kind of hold seeds, but they can spill. These ones are a little mushier. So basically there's definite pods. You tend to have very small seeds in these. There's definite pods, and they tend to hold the seeds in if they're undisturbed, but an animal, strong wind could essentially have all those seeds kind of go tumbling. Some of these too will start to droop at the very end of their maturation process. So they'll be holding the seeds, they're maturing, drying nicely, and then over time they slowly droop, at which point they can just pour the seeds out. So you've got lots of your poppies, your evening primrose here, columbine, and these do tend to have quite small seeds in larger pods. And so for these, you know, just collect those stalks when they're visibly dry. It's okay if they're not as dry as they could be, you know, but you can collect the whole pod. You can empty out the seeds to wherever you're going to dry them and take it from there. And then other flowers that don't have those visible pods, you know, you might have your composite flowers where you've got actually each flower head is multiple flowers. And so for these, the seeds are going to be located each of these heads. And so a lot of times with these types of flowers, we'll see the seeds just drop gradually as the head matures and deteriorates. This is always just kind of a game you can play as far as, are you going to let the seeds mature longer on the plant while running the risk of, you know, wind or animal taking it away? This is a particular thing with sunflowers. It's like, how long can you keep those seeds on the plant before something eats them? So to be safe, you can choose to just harvest the, you know, by cutting the stalk, harvest when the petals have dropped, and you can let those fully dry off of the plant. So again, leave on the plant as long as you can, but a lot of times it depends on kind of your wildlife situation in your location. A lot of times it's not as long as we might like. And then if you see others like your marigolds that will kind of enclose the seeds, this is great. I think it's nice. So in that case, you can just wait for that flower to dry on the plant. And then you'll want to harvest again, kind of the whole flower, and do a little bit of work processing inside or in a container. And we will talk about some methods for that in just a sec. So for processing dry seeds, no matter what kind of seeds you're dealing with, the kind of concepts are the same. So whatever it is that you harvested from those flowers, let's say, you're going to have a mix of seed plus other stuff, which is called chaff. So you want to first do what we call threshing, and this is physically detaching the seeds from whatever they're encased in, whether it be a head, a pod. There's going to be some points of physical attachment, and so threshing is simply loosening everything, and then you're going to end up with a seed and chaff mixture. So they'll still be all together, but they are not attached to one another. And you can thresh by hand. So like if you are dealing with, let's say, a pea pod, it's easy to imagine you're threshing by hand. You're just opening up the pod, throwing it in the container, no big deal. A lot of times, if you have a little bit larger quantity, you can use a pillowcase or a bag and kind of whack it to kind of crush things up, detach things a bit. Similarly, you can apply light pressure between two boards, again, to just crack open anything that needs cracking open. So once you thresh, however you choose to do so, you have a seed and chaff mixture. And then you want to separate the seeds and the chaff. There's a couple ways of doing this, often used in combination, called winnowing and screening. So the equipment you might want for this is screens, sieves, colanders. It's really helpful sometimes to have implements of various sizes. So you can kind of take this example here, this kind of progression. So first we've got, this is our seed and chaff mixture, right? So we can see things are separate. It's just that it's a pain to get them, things are detached, but it's a pain to get them separate. So this is going to go through screen. I believe this is actually taken through 3 different size screens before getting to this picture here, at which point you're just kind of carefully separating as best you can. And you know, it's important to remember if you have a little bit of chaff left, that can be okay. But the other place we can look for help, further help, is this photo, which is an example of winnowing. So winnowing is where you separate seed and chaff based on weight, relative weight. So you can see there's a picture of a fan here. So this was done well before fans, but essentially you're pouring in front of a fan, and your heavier seeds, once you've done some of that preliminary screening, that's important. Your heavier seeds are going to drop into your container, while the fan, the wind from the fan, blows away the lighter chaff. And that's actually can usually get your pile pretty clean as a last step. Okay. So drying seeds. So we talked about when you want to harvest wet seeds, when you want to harvest dry seeds, the differences in processing them. But here is where their paths remerge. So you definitely want to, you're going to need to dry any seeds regardless of the journey they've been on. So this is one of the questions that came up. So seeds can store for up to 10 years if dried to less than 8% moisture. And this is definitely going to, this is a general statement. This is going to depend on the plant. And we're referring generally here to flower and vegetable seeds for the most part with those numbers. To get to 8% moisture, how do you do it? You can dry at 100 degrees for 6 hours. So dehydrators are good for this if you have them. You can use an oven. You do not want to, you would leave the door open. So oven with the door open at 100 degrees for 6 hours. Dehydrator, you never want to use a microwave. And then something to remember is that over drying can affect the germination rate, and you can kind of have an effect on the moisture in your seed in 2 stages. So right here, when you're drying that seed before you're going to store it, is really what you want to focus on. But the relative humidity where you store the seed, you know, will have a push and pull effect. And so this fact sheet, storing vegetable and flower seeds, has a specific list of the needs, the shelf lives of specific seeds. So that is, again, will be sent out to you with resources and link to the presentation. One thing also, that's just a little quick test that you can look at as far as, am I at a good level of moisture for my seed? An easy quick test is when you try to snap a seed in half, you want it to in fact snap rather than bend. That's kind of a good indicator. Obviously not super scientific, but commonly used. So you've got to around, hopefully under 8% moisture. Storing seeds, you want a dry and cool environment. Ideally, it would be great to be under 40 degrees. But something to keep in mind is that your temperature and your relative humidity in the environment where you're storing it have a combined effect. So you can achieve similar storage life. If you have a lower temperature, you could have a little bit higher relative humidity, and vice versa. If you have higher temperature, you're going to want a little lower relative humidity. Vegetable and flower seeds in Colorado can store on a shelf in Colorado for a year or so, no problem. This is, again, after you have properly dried them. So storing after you've dried them, they can last a year, shouldn't have a big effect on germination rates. You know, as you kind of move away from the ideal environmental conditions we're talking about, it's not that all the seeds, you know, just give up. It's that you're just going to get lower germination rates over time. So something to keep in mind. It's a bit of a spectrum. And so you do want to keep that moisture low we're talking in the environment where you store it, but lower than 5%, some seeds can start to crack. And so ideally you want to store in a moisture-proof container for the best longevity, and label, label, label. So record keeping is really something you're going to need to do every step of the way. You know, here we can see we're just drying some cleaned seeds, and at that point you need to have them labeled as well. You know, here we just have the species and variety and the date. So presumably, hopefully, all this other information is covered in a very thorough journal entry. Because you want to, at a minimum, have your plant name, genus, species, and cultivar, if you know it, the date collected, the location collected. And I would add that as you're experimenting, it's a good idea to really take good notes on your process, because I think that that's the whole point, right? We make mistakes, we learn, and it's a lot easier to learn from your mistakes if you know what they were. So you also want to do, when you're ready to potentially use the plants the following season or seasons to follow, you want to do germination tests. This is super simple. You are going to take out seeds of a known number. Kind of even numbers are easy to deal with. So you could do 10 seeds and get a, you know, that'll probably be the minimum you want for a decent germination test. Or if you want to get more specific, you could do 100 seeds. You could do 20 seeds. But long story short, you're going to take those seeds out, put them in a moist paper towel, cover them. A lot of people do this in, I like to do it in like a Tupperware, but most seeds will germinate. They're not too picky at this stage. You just want to be careful that you're keeping that relative humidity high enough for them to want to germinate, not too cold, but you don't want to encourage mold. So it's good to have some air circulation as well. And so then give them the time, and you know, once you start seeing your first ones germinate, if you want to do a little bit more advanced test, you can test not only your total germination, but how many germinated on day 3, day 7, whatever. But all in all, you're gonna know your total number of seeds, and you simply count how many germinated, and there is your germination test. And so that's good for knowing how many seeds to plant, you know, what kind of variation you want to account for. And then another thing to keep in mind, last but not least, because I think this is what a lot of people were referencing and having issues with. So we can talk about these in a little more detail. So a lot of the things we've been talking about, vegetable seeds, annual flower seeds, again, focusing on the easiest, don't require this. But what makes a lot of the more advanced seeds more advanced is that some plants will need special treatment on the seeds in order for them to germinate. And so this is basically they need treatment that simulates the weather, climatic conditions and patterns they would be going through in the wild, or they're not going to germinate if they're not given those signals. So for example, scarification, which a lot of times is simply scratching the surface of a seed. So that helps break that physical dormancy if you have a really extra thick seed coat. And if I'm not mistaken, that's what the issue with nasturtium is. There's also stratification, which, so if you do, let's say, cold, moist stratification, you might need to put a seed in with a wet paper towel in the fridge for 4 months or in the freezer for 3 weeks. And what that again does is it simulates the signals that seed would be getting were it naturally dispersed in the ground and going through a fall, winter, and early spring. And it needs those signals to break, usually a chemical dormancy is what that is. So it needs those signals to create certain plant hormones that signal it to break that dormancy. So yeah, that is where seed saving definitely strays from the super simple, is when you get into those the special treatments needed. They're absolutely doable, but when you get into the perennials, for example, there's a lot more of that. And so it's just something you always want to check for. Okay. And just remember, this is a low stakes game. That's why it's awesome. So start small, start easy, and just save what you love, keep good records, and have fun experimenting. So these are, again, these will be sent out with active links, but these are the various resources that I've referenced in the slides. So just know you'll get those. And then some reminders. As Darren mentioned at the beginning, you want to register for upcoming classes on the cohorts blog page. That is theoretically where you registered for this one. Next up Thursday, there's planning and establishing a vegetable garden with a guest speaker, Don Weiss. And then next Friday, Darren's doing basic landscape design and planning. So those should be awesome. And then there's more after that. They just keep coming. As a reminder, the recording of this presentation, when it's available, will be posted on that same page, on the cohorts blog page, right where you registered. And the resources and evaluations will be sent to whatever email address you use, so keep an eye out for those. And I also just want to do a plug that most counties right now, including us in Broomfield, are recruiting for our next crop of Master Gardener volunteers, which we're really excited about. We're using a lot of the resources from CSU Online, and we have 100% online or remote learning options, as well as some counties are doing limited in-person labs. So it's going to be a really cool, different year, and we're excited. So if you want to apply to be a Master Gardener in your county, you can do that directly through your county or on the State Master Gardener webpage, and I will send you all those links. And we're also doing Green School, which is some or all of those same classes from subject matter experts, but without the volunteer requirement that the Master Gardener program is built upon. So thanks everyone for joining us and spending your lunch with us. I will pop in the chat and see what's going on. If anyone has more questions, I would love to answer them. Let's see here, let me get to the top. Oh, and so Candace, going back, so lupine seeds, that is definitely the scarification, I think, is their main issue. They probably have a little bit of both, and that's a great example. So Candace had asked at the beginning, will you get to things like lupine seeds and their challenges? That's a challenge with a lot of your native seeds. And actually, natives are another great kind of cause for seed saving, but they often, very often, require special treatment. Let's see, does the cover for wet seed fermentation need to allow air through? So I would recommend that you either, you could have a regular lid jar, but don't screw it on super tight, or have a cover like I showed that lets a little bit of air through. And this is just because the process is going to create some gases. So if you have a super tight lid, those might build up. So I would say, I guess, yes, a little bit of air. I have echinacea outside that dried. Would last night's below freezing temp mean they are not viable for saving? Nope, it would not. That should be just fine. Should you store seeds in the refrigerator? You certainly can. Looking at an ideal temperature, again, about 40 degrees, we're going to be a lot closer to that in our fridge than we are out and about, but I think it depends on kind of space in your fridge, moisture in there. That would be a concern of mine, but yeah, sure. I mean, that can certainly be helpful. Something like a unheated garage is a lot of times a good temperature at certain seasons, but it's variable. So you can certainly store them in the fridge, but really just getting somewhere that they don't have lots of temperature fluctuations and they don't have very high temperatures is usually sufficient. But if you have some prized specimens, go for it. Do you ever do classes on gardening pests? Yes. I'm trying to think, Eric or Darren, feel free to jump in. I'm trying to think if there are any upcoming. The short answer, yes.
Yeah, earlier in the summer we had Japanese beetles, and I think there are a few other ones. So if you go back to the webpage where you found this, we have recordings of several of the talks, and there might be some there.
And I would add that probably if you keep an eye out for next spring, a lot of those pest talks end up being more summertime talks, so.
Thanks, y'all.
Maybe.
And thanks for reminding me I have my video off. Sorry, that was a talking ram head. Okay, let's see. Thank you, Joanne. That was great. Appreciate that. How do we find out more about Green School? So it is on the Colorado Master Gardener State webpage, and I will send that link to you with the other resources. And if you happen to just have your browser up right now, it's cmg.colostate.edu. And how about I just use the chat like a normal person? There you go. That link is in the chat now, and I will also send it out in the email. Let's see, going up here. Green School. Okay, can you help me with zinnia seeds? How do I identify, separate, and store? As far as identifying, I would think you would, you would start with a plant. I do know that some people actually have some, I've heard this reported before, issues with zinnia seeds because they can kind of be of different sizes. But essentially, you are going to follow the protocols for like the heads that kind of gradually drop their flowers. Gradually drop their seeds rather. So if you're losing a lot of seeds, you can cut off the flower and everything a little before they're fully dried. You're gonna let them dry just on a paper plate or what have you, just like that, the flowers and whatever else you cut off. Then you're gonna go through that separation of separate it into the seed and the chaff, and then strain it. And then of course, dry more and kind of go through that whole process. Does the drying require heat oven or dehydrator? No, good question. Thank you for asking that. Absolutely, it does not. You could also leave it just outside. It's ideally, you don't want to leave it in full sun just because we're not in very good, we don't have control over that heat, but no, you would just leave it for longer. And you do not have to dry with heat. Right. Is it better to store seeds in paper envelopes or plastic envelopes, Ziploc tops? You can do either. If you have something like a paper envelope, you do ideally want to have something on the outside. Like I often have lots of paper type envelopes within a big Ziploc usually. So at some point you want to have an actual barrier to moisture. So, but it's nice to have that breathability as well as not waste a bunch of plastic by doing like a lot of little Ziplocs. But either one will work, but you are just trying to control the moisture, which you can do better with. They're not permeable. Any wisdom on tiny seeds? Yeah, so those are tough. I mean, those fall into the category of they'll be held and then they can just kind of spill out. So harvest them a little early if you're losing them. Harvest them a little early, just put them in some kind of preliminary container and let them dry out there. So, because I think a lot of the issue is a lot of times we don't even know what's going on. The seeds are so small and then they're gone. So harvest them a little early, put them in a preliminary container to dry for a few days. But the screening and all that is actually easier on small seeds. And I would just keep in mind, if you haven't approached it this way before, you can use screening in two different kind of directions. You can go progressively larger holes or progressively smaller holes. And so sometimes if one's not working for you, the other can. Do avocado seeds produce fruit? They do, they can. They don't store. They need to be, so that, and yeah, that's another good example of just something that, I was gonna say advanced, but I know many of us have grown avocados like in the window when we were kids, but not advanced, but just different. You don't, they cannot dry out all the way. So we don't store them, but yeah, they can. How about milkweed? Collect now before they burst, and then what? Go in the fridge. Can we disperse seeds where we want them now? So milkweed, yes, collect before they burst. You'll still want to, even though, you know, you bring, it's a good point, the dry seeds that burst, they do tend to be drier before you harvest them because they're getting ready to be dispersed. My advice to you would be this: if you just disperse seeds where you want them now, that is a good idea because it takes care of all of those things like that you have to simulate of that seed going through the seasonal changes. However, if you're just going to disperse them now, I mean, you don't have to do any of the processing, none of that. You can even let them disperse themselves. But a lot of times, yes, I mean, fall is a fine time to plant seeds potentially. But I think if that's your plan, it sounds like maybe you just want to redirect them a little bit. Yeah, don't feel the need to go through all the processing. So Derek asked, does nasturtium like scarification? That is my memory. Is that Eric and Darren? Nasturtium like scarification? I don't know.
I don't know either. I have never done scarification and they have come up fine, but perhaps sometimes they do.
That is my experience too, actually. But well, I think I have, and I think I freaked out at first. And I have done scarification, but then I think I got lazy and they still came up fine. A couple of people have asked about them, so maybe they're having issues, but thinking about that kind of thicker, rough seed coat, that seems right to me. So yeah, Derek, if you are not confident in our answers, you can email me directly, but I am pretty sure. Thank you, Liz. Is there an on-site resource that provides Seed 101 guidance by plant? As far as that big chart that I showed you a snippet of with peas, that has a lot of information. So it's got like pollination method, you know, separation needed, all those categories I showed you, and it's got a really extensive list of plants. So hopefully that does the trick. And once you receive that, if that's not what you're looking for, feel free to email. Is there a resource that comments to some of the special seed planting instructions? You know, usually you can find that stuff really easily on when you get the seeds. And I'm sure there is, I'm sure there's a resource. I'm not familiar, thanks Darren, of one that has it like nice and tidy. But if you have the seeds at first, that information will be on the seed packet. Sometimes seed companies will pre-treat for you, so look for that too. But I will, if you wouldn't mind emailing me directly that specific question, I'll look up a good neat and tidy resource for that. That's like bowls. Darren sent the link to the webinar. And you have to dry all seeds in the dehydrator or just the wet seeds? So you will need to dry all seeds. It doesn't have to be in the dehydrator. Wet seeds are going to need overall more drying. You want to get the seeds to not so different a moisture level for storing. Let's see. Thank you. Darren sent the Green School info. Next year will be my first attempt at using seeds. What's a good resource for learning how to do this successfully? So Liz, if you mean planting seeds, I would recommend the Grow and Give website, which is a place that starting this year, we, CSU Extension, have been collecting all kinds of largely food production resources and lots of good seed starting stuff. So it's Grow and Give. I put that in the chat for you, and I'll make sure to send it out in the email as well. So someone said how to store seeds of fruit like peach, plum, cherry, etc. that have hard casing. So a lot of those have, need vernalization, a cold treatment. It really varies what they need. And the other reason we don't really address those is that the pollination, fertilization requirements of Your tree fruits and palm fruits is they vary wildly and they're somewhat complicated. And so remember, a lot of times they won't come back true to the parent plant. However, you can save them. I find a lot of people, when they try to grow from those saved seeds, the issue is that they don't give it a cold treatment. Jan asked, what's the difference between the Master Gardener certification and the Colorado Gardener certification? So it's can be all the same classes. You have the option to kind of be a little more selective with your classes with the Colorado Gardener certification. In case it's not clear, if you're familiar with that program before, Green School is a new kind of branding of the Colorado Gardening Certificate. So it can be all the same classes. There can be some differences, but the biggest difference is that the Master Gardener certification comes with then a year commitment for a certain number of volunteer hours. You also get continuing education as part of that. So that's the big difference. And I think maybe I made it. I made it. And 2 minutes ahead of time. I'll hang out for a sec if anyone has other questions, but it looks like we've reached the end. So thanks everyone so much.
You're getting lots of thank yous and kudos. So excellent, Sarah. Thank you. And we hope that